So far, the only type of series that we've talked about is the geometric series, where you're multiplying the previous term by the same number to get to the next term. And we know that a geometric series converges if the absolute value of that common ratio r is less than 1, and the sum of the geometric series is a over 1 minus r if it converges. Now, not every series is a geometric series, like 1 plus 1/3 plus 1/5 plus 1/10. That is not a geometric series. It is a series. You're adding a whole bunch of stuff. Another way to tell if a series converges or diverges is what's called the nth term test for divergence. Again, make a note card on any of these things that are in boxes. And what the nth term test for divergence just tells you is if it will tell you whether the series diverges for sure or not. It will not tell you whether it converges. So that's why it's called the nth term test for divergence. Basically, intuitively, what it says is if the limit of the general term is not 0, then you can say that this series for sure diverges. Basically, if the terms are not getting smaller, which is what it means that that limit is 0, so if all those numbers are getting bigger and bigger, for example, 1 plus 3 plus 7 plus 10 plus 20, there is no way that this infinite series could possibly converge to a sum because you're adding bigger numbers. So what the nth term test says is if that limit of that general term does not get to 0, then you can say for sure the series diverges. However, if that limit is 0, then this test is inconclusive. We would need some further information to figure out if it actually converges or not, and we will learn some other ways to figure that out later on. So the following list of questions asks you to tell me whether the series converges or diverges. And right now, you only have two methods to determine it. Either A, it is a geometric series, and that's what you want to check for first. If it is not a geometric series, then you're going to use the nth term test. So the first one. In a geometric series, you have to have everything being raised to the nth power or possibly just a constant multiple. So I notice in this problem, my r value is 2 because the 2 is being raised to the nth power. Or if you want to list out the first couple terms, that would be fine. The first term is 1 plus 2 squared plus 2 cubed plus ... We can clearly see that this is a geometric series. My r value is 2. You tell me it is a geometric series. You need to tell me the r value, and then the conclusion is that it diverges. You're done. Okay, number 2. Number 2 is not a geometric series. I do not see anything raised to the nth power. Or, okay, actually there's a typo. This first term should start at 1 because you can't divide by 0. Or if you list out the first couple terms, 1 plus 1/2 plus 1/3 plus 1/4, you are not multiplying the previous number by the same number to get to the next one. So this is a series. It is not geometric. So in order to tell whether it converges or diverges, the only option you have is to do the nth term test. So when you guys are doing these problems, write that you're using the nth term test. Your work would be showing me that you are taking the limit of the general term, which in this case is 0. So the nth term test for divergence tells you that it is inconclusive. So more info is needed on this problem. I do not know whether it converges or diverges. Number 3. Okay. I do not see things being raised to the nth power. This is not a geometric. So I'm going to use the nth term test, which means I will take the limit of the general term, n factorial over 2n factorial plus 1. This limit is 1/2. You can check on a calculator, but pretty much you do it the same way we do when we have powers. The factorials are the same, so you do the ratio of the lead coefficients. This is not equal to 0, so I can say for sure that this diverges, right? The nth term test says if the limit is not 0, you can say for sure it diverges. Okay, number 4. Again, not a geometric. Let's do the nth term test. I'm going to take the limit of the general term. This limit is 1/5. Again, not 0. So I would say for sure this diverges. I would go ahead and pause the video and you try the next 4 examples on your own and then come back to check check your answers. Okay, number 5. I see that this is a geometric series, so tell me it is a geometric series. Tell me what your R value is. R is 1/3. Absolute value is less than 1. Converges. Number 6. Not a geometric, so I'm going to use my nth term test. Take the limit of the general term. Now, if you plug in infinity, you will get infinity over infinity, and you can use L'Hopital's rule if you like, or if you understand that the log of a function grows slower than the function itself, you know that this limit is infinity, which is not 0, so I can say it diverges. Number 7, not a geometric, so I'm going to use the nth term test. Take the limit of the general term, which is 1/2, so you need to be able to tell me the limit. Again, if the limit is not 0, then you can say for sure it diverges. Okay. And the last one, number 8. This is not a geometric, even though this 2 is being raised to the nth power. If you had that by itself, yes, it would be a geometric, but then on the bottom you have the n squared. So this is not a geometric, so you do have to use the nth term test. I'm going to take the limit of the general term, 2 to the n over n squared. Again, you will get infinity over infinity. You can use L'Hopital rule a couple times, or I know if you understand that an exponential grows quicker than a quadratic, I know this limit is infinity, which is not 0, and I can say for sure this diverges by the nth term test.